Napindot ka ba? Ayan. Okay, so let's now proceed with the last part of our discussion for the midterm, solubility equilibrium. So last time we were able to cover all this stuff about acids. No, we defined acids in three manner. So we have the Arrhenius, the Bronsted-Lowry, and the Lewis. No, so ayan, ang gamit natin dito ay yung Bronsted-Lowry, no, because it tells us that acids and bases have their conjugate pairs, no. And if you have a mixture of the conjugate acid-base pair, pag may mixture ka ng conjugate acid-base pair, you have buffer solutions, which is vital to your study, no. Buffer solutions are solutions that resist the changes in pH, no, as they try to maintain balance, and they are also governed by the Henderson-Hasselbalch equation. Okay? So, yun. Dalawa yung uri ng acids natin in terms of their strength. There could be a weak acid, meron din strong acid, merong weak base, strong base. Anong difference lang nila? For weak acids, the dissociation is less than 100%. No? So, there are a lot of factors that could contribute for that. Number one would be the molecular structure. Maybe they possess resonance. That's why the hydronium ion isn't protonized very well. So, hindi siya na-ionize very well. Another factor would be the bond polarity. So, if the bond polarity is low, yung electronegativity difference, that could result for a weak acid. No? Or another thing is yung hydrogen bonding. Usually molecules that possesses hydrogen bonding, they are weak acids, no? Kasi clingy sila masyado. Example would be acetic acid, COOH, yung OH doon, hydrogen bond yon. Ammonia, weak base yon. Yung NH bond doon, weak base yon. And hydrofluoric acid, HF, weak acid din yon kasi hydrogen bond na. So, yun yung mga factors, no? However, it will be more convenient, no, kung kabisado mo na lang sila. Kasi that was my technique also. Ang dami kasing factor that can contribute sa strengths of acids and bases, no. So minsan they are true, minsan they are not, no. So it would be better if you will be familiar with them na lang. Okay. So ginawa ko dati, kinabisado ko na lang 'yan. Okay. Para easy na. Okay, so for strong acids, the concentration of your ions can be calculated using stoichiometry because the dissociation is full. You can do stoich, no? Kunwari, you have 1 mole of your acid, it will produce 1 mole of the ions as well. No? So, yun yung pag strong acid or strong base. No? So, 100% yung dissociation. Hence, you can infer of their amounts using stoich. No? However, for weak acids and bases, you have to do equilibrium calculations because only parts of your initial amount will dissociate into ions, and that can be described by K, no, the equilibrium constant. So that means you have to use the ice table, and I shown you some technique last time, yung calculator techniques, and then yung uh, small x approximation. So those are enough para masagutan nyo na yung quizzes. And then also, depending on the number of hydrogens our acids can give off, we can have diprotic and triprotic acid. So kapag diprotic acid, dalawang H yung bibigay niya. Pag triprotic, tatlong H ang ibibigay niya. Okay? And take note that when these acids dissociate, they do it stepwise. So, isa-isa yung pagtanggal ng H. No? So, let's say for sulfuric acid, dalawa yung dissociation niyan. And for phosphoric acid, tatlo yung dissociation niyan, H3PO4. So, ganun. So, stepwise yung paglabas ng H sa molecule when you have diprotic and triprotic acids. And each of those stages are characterized by Ka values. No? So, they are characterized by different K values. Okay? So, yun yung kailangan nyo i-take note. Okay, so yan yung coverage natin dito. Let's now focus on the last two. Mabilis lang yan. So, let's talk about the solubility equilibria. I know you have an idea kasi ito na rin yung ginagamit sa lecture for the ionic activities, di ba? Solubility equilibria yung examples doon madalas eh. So, yun. So, look at our equations here. What can we notice is that yung ating reactants ay solid. And they are solid because they are precipitates. No? Silver chloride is a precipitate according to the solubility rules. No? Magnesium fluoride is also a precipitate. Um, Silver carbonate, precipitate din yan. Calcium phosphate, precipitate din yan. So, basically, when we say solubility equilibria, this describes the ionization of our precipitates into their corresponding ions. Okay? Again, pag sinabi natin solubility equilibria, nabubulol ako. Pag sinabi natin solubility equilibria, this describes the dissociation of our precipitates into ion, di ba? Pero baka isipin nyo, di ba? Sabi ko last time, pag precipitate, solid yon. So baka isipin nyo, sir, bakit sila nagiging ion? Okay. So nagiging ion sila to a small extent, to a very, very small extent, no? Okay. So, masyadong maliit lang yung chance na maging ions sila. But still, because they can produce ions, we can quantify them. Okay. So, kaya dinidiscuss natin siya ngayon. So, again, these precipitates are not really solid, no? Only portions of them dissociate. Kaya nga, isa pang tawag sa precipitates ay sparingly soluble salt. Hopefully, nabasa nyo to sa lecture. Sparingly soluble salt. Yan yung isang tawag sa precipitate. So, sparingly, that means to a very small extent yung solubility ng ating precipitate. Okay? So, onti lang yung na-dissociate into ions. Okay? So, yan. Ito yung equations that describes the dissociation of our precipitates into their corresponding ions. Take note that the stoichiometry is followed. Yung mga subscript, ginagawang coefficients. Okay? And if we write the K expression for this, makita natin na wala tayong denominator for here, no? And this is actually unique, no? That's why it is called the Ksp. Okay? So yung equilibrium constants for the solubility equilibria, they are called the Ksp kasi unique sila. Bakit sila naging unique? Wala silang denominator always. Bakit? Kasi solid yung denominator nila eh. So, only the numerator is given. Okay? So, yan. This is unique. So, that's why it's called Ksp. Ang meaning ng Sp ay solubility product. Okay? That's the product of the soluble ions. No? So, again, solubility equilibria describes the dissociation of our precipitate into ions, and they can be described by Ksp, the solubility product constant. Okay. So, numerator factor lang meron tayo dito. Wala tayong denominator for the reason that yung ating reactants ay solids. Okay. And of course, each of the precipitates, meron silang Ksp values. No? If you can check, kung may copy kayo, no, pwede zoom in nyo na lang. As you can see, yung ating Ksp ay raised to negative numbers. No? Bakit? Kapag sinabi nating negative number yung exponent ng K, that is, mostly reactant yung natitira. Okay? So, ibig sabihin, onting products lang na form. Especially if your exponent is, let's say, negative 33, negative 14, negative 28, negative 72, di ba? Masyadong malaki yung negative value for the exponent. That means, onti lang talaga yung nasa product side, no? Pero still, pag hindi naman pag sinabi nating onti yung nasa product side ay wala na sa product side, no? Still may products pa rin tayo mabubuo, no? Okay, but to a very small extent. And since this is anachem, we are going to quantify them. Okay? So yan, so ito yung mga Ksp values for different salts. Ang manonotice natin, they are raised to negative numbers. bigger negative numbers compared to Ka and Kb. So that means that these compounds are not really soluble, no, compared to other compounds. Okay? Kaya ang tawag dito sa kanila is solubility equilibria. Okay? Other terms that are used to describe the solubility of our precipitates are the molar solubility and the solubility itself. Now, so when you say molar solubility, this tells us about the moles of the substance dissociated in the solution. Okay? So again, pag sinabi molar solubility, ito yung moles of the substance dissociated sa solution. Okay? So yan. So molar solubility yan, that means it has units of molarity. So sinasabi niya, gaano kaonte yung na-release? Yun yung molarity nun. Molar solubility, tawag doon. Okay? However, yung ating molar solubility, you can convert it to the gram solubility. I call this gram solubility. Bakit? Kasi instead of expressing it in moles per liter of solution, we express this in grams per liter. Okay. So, paano mo makukuha yung solubility from the molar solubility? Easy. You just multiply the molar solubility by the molar mass of your precipitate. Okay. So, multiply mo lang siya sa molar mass ng precipitate. You will get this. And from this, kung gusto mo kunin to, you just divide it by the molar mass. Okay. And here's the usual flow of calculation here. So, for example, you are given a solubility of compound. Gusto ang Ksp hanapin. So, you convert the solubility to molar solubility. Then, whatever the molar solubility is, you plug it into the ice table. Then, pagka-plug in mo sa ice table, you can get the K. Okay? So, magbibigay ako ng example na ito sa worksheets. No? But for our session today, ito yung gagawin ko ay nasa baba. So from our Ksp, we will get the molar solubility and later on the solubility lang. No? So ito lang yung gagawin natin. This is the same, no? Same concept lang to, however, reversed yung process. So sa worksheet ko na lang i-upload to, ha? Okay, so ito yung gagawin ko today. So let's start, no? So we are all familiar with how to solve using ice table naman. So mabilisan na lang tayo. Suppose this is the question, what is the solubility of silver chloride in grams per liter? Okay? So hinahanap sa akin yung solubility in grams per liter. So that means I will start with the K value. Okay? So yung kasi sabi dito, kung hinahanap solubility, you start with the K expression. So for silver chloride, what is the reaction? So you start with the precipitate ng silver chloride, it will dissociate into Ag plus and Cl minus, di ba? So yan yung mangyayari sa ating precipitate. It will dissociate into ions. But to what extent? Okay? Ang magsasabi sa atin ng extent na yon ay yung Ksp. Okay? So to what extent? Ksp magsasagot nun. So let's look at the Ksp value for Agcl dito sa table natin. Okay, so ito Agcl. Okay, pantay ba? Okay, so for Agcl, the Ksp is 1.6 times 10 raised to negative 10. 1.6. Okay, so ibig sabihin ganyan lang kaunti yung ating products na mabubuo raised to a factor of 10. No? So yan, so ganyang extent lang according to the Ksp. However, we are looking for the actual amounts. No? So we need to use the ice table kasi equilibrium to eh. Okay, so let's plug in this info sa ice table. So we have Agcl, Ag plus, and Cl minus. Okay, so siguro magtataka kayo, no? Ba't ko nilagay yung Agcl? Di ba sabi ko kapag solid liquid, wag ilalagay? Okay. Ang reason ba't nilagay ko yan kasi tatlo kasi yung column dito. So, iba-blank lang natin talaga yung Agcl. No? Okay. So, indicating that Agcl, although it is a reactant, it is not considered sa ating equilibrium expression. It does not affect the equilibrium equations. Okay? So, only the ions matter. Okay? So, yan. So, again, pag ganito yung problem nyo, you're given the salt, hinahanap yung solubility, you start writing the equilibrium expressions and their corresponding K. And then later on, you construct the ice table. So, since wala nang info sinabi sa atin about the initial state of our system, 0 yung ating ions. No? Walang sinabi sa problem eh. So, 0 sila. Then for change, obviously, sabi ko last time, kung nasan yung 0, dun yung positive. So this will be positive x. That will also be another positive x. Okay. And then at equilibrium, you're just going to add the I and the C. Pag-add-in mo lang sila. Also, please be reminded, kapag meron kayong coefficients, you have to include it sa C, sa change, ha? Kunwari may 2 dito, lagay mo yung 2 doon. Kunwari may 3 dyan, lagay mo yung 3 doon. Don't forget that. Okay? So, ganun lang. And then, you can do the usual you can do the usual equilibrium calculation to solve for x. So, alam nyo na naman kasi to. So, plug in nyo na lang. So, Ag plus is x. Silver is x. So, we get Ksp equals x squared. To solve for x, that is the square root of Ksp. Okay, diba? Easy lang. Mas madali siya compared sa acids, no? So, kasi ganyan lang eh. Okay, so yan. So, ganun lang. Makukuha na natin yung x. So, the x value is, bakit pindot na lang sa calculator niya? The square root of 1.6 times 10 raised to negative. So, that's 1.26 times 10 raised to negative 5 molar. Okay. So, pero, ano yung x, no? Ano ba yung value ng x? Okay. So, the value of x is actually the molar solubility. Diba? Ito na yung molar solubility pag hinahanap sa inyo. So, compare nyo yan sa acids and bases. Diba, pag na-solve nyo yung x, babalik pa kayo sa equilibrium. Diba? Ipa-plug in nyo pa siya dito. But, for solubility equilibria, kung ano yung x value, yun na yung molar solubility. No? So, yun na yung sagot natin. Ito na yung molar solubility. Unless, ang tinatanong sa inyo yung concentration ng ions. Okay? Pero, pag tinanong molar solubility, that is just the value of x. Okay? X value lang yun. So, yan na yun. Malapit na tayo matapos. Then, to convert the molar solubility into solubility in grams per liter, anong gagawin nyo? You multiply this by the molar mass of silver chloride. Okay? So, ganun lang. So, we multiply this, okay, mole per liter by the molar mass of silver chloride. So, the molar mass of silver chloride is 143.32 grams. Okay, so you can see the moles will cancel, giving us the final units grams per liters. Okay, so the solubility is 1.8 times 10 raised to negative 3. Or in decimal, that would be 0.123. Okay, so this is our final answer. Yun na yun. So, we're done. So, as you can see, madali lang calculation, no? So, you still follow the typical rules sa ice table. However, because wala tayong reactant, wala sa denominator, mas mabilis mag-solve for the value of x. No? So, mas madali na mag-solve for the value of x. Okay, so yun lang. So, whatever the x value is, that is the molar solubility na. Kapag yun yung hinahanap, stop na kayo dyan. Pero kapag hinahanap yung concentration ng ions, you have to plug it dito. Pag hinahanap naman is the solubility in grams per liter, you multiply it by the molar mass. O suppose, reverse yung nangyari. Given sa inyo yung solubility. Let's say, given yung molar solubility, hanapin mo yung Ksp. Pwede ba yon? Pwede. Pag ganun yung technique, gawa muna kayo ice table so that you can write the correct expression for the ice and yung corresponding x values nila. Kunwari, ito 2x, ito 3x, and then yung mga corresponding coefficient nila. Then since alam mo na yung x because of the molar solubility or the solubility, yun yung ipa-plug in mo na lang doon. Okay? Pagka pilinag in mo yung value ng x dito, you will get the Ksp. So again, sa worksheet ko na lang ilalagay yon. Okay? Kasi yun ay ano na lang. I'm sure familiar na kayo kasi naggaganon tayo sa acids, di ba? Remember, pwede natin makuha yung Ka sa acid using the equilibrium amounts. Ganun din dito. Dx is the equilibrium amount. Okay, so you just plug it into your K expression, you will get the Ksp. Same concept lang, nothing new. Okay, so ganun lang. Also, since madali lang yung equilibrium equations dito, may shortcut na tayong dinevelop. Okay, so this shortcut is pwede kabisaduhin, pwedeng hindi, no? This is derived from the equilibrium expression of different ions, no? Of different ionic compounds. Okay. Depending on the ratio of your cation and your anion, there is a corresponding equation to solve for the solubility, the X, or in our case, letter S. Letter S kasi nakalagay dito eh. Okay. So, itong S, X din yan, no? So, yan. So, depending on the type of your compound, you can have different ways to solve for the X. Saan galing to? Sa Ksp lang din. Okay? So, for 1-to-1 ratio, 1 cation, 1 anion, pag 1-to-1 yung ratio nila, your solubility can be calculated as the square root of Ksp, or Ksp raised to 1/2. Again, that is kapag 1-to-1 yung ratio nila. Example niyan is silver chloride and barium sulfate. No? So, isang cation, isang anion yung mapoproduce mo. So, 1-to-1 yung ratio nila. So, you can solve for X as the square root of Ksp. Katulad lang ng ginawa natin dito. X is just the square root of Ksp. Okay? Pwede ka bisaduhin nyo na lang din to. Okay? So, paano naman kapag 2-to-1 yung ratio nila? 2-to-1. For example, dalawang cation, isang anion, o kaya isang anion, dalawang cation. Pag 2-to-1 ratio, the equation to solve for X or S is the cube root of Ksp divided by 4. Sigurong tataka kayo. Saan galing yung 4? Okay, saan ang galing yung 4 na yun, sir? Bakit siya naging cube root? Okay, galing yan sa equilibrium constant. Okay, so kuha tayong isang example dito. Kunin natin si lead-2 fluoride. Lead-2 fluoride. So pakita natin, it will dissociate into lead-2 plus and 2 fluoride ions. At equilibrium, sa ice table, this will be X, this will be 2X, di ba? And if we write the Ksp, that will be the concentration of lead-2 plus times the concentration of fluoride minus square. If you plug in the equilibrium expressions dito sa K, you will get X times 2X raised to 2. Itong 2X raised to 2, ito yung reason ba't may 4 doon. Okay? So, that will be 4x cubed. Bakit naging x cubed? Kasi you have x squared times another x. So, magiging x cubed yan. So, to solve for x, that will just be the cube root of Ksp divided by 4. So, dito galing yan sa equilibrium expression. Kaya nga sabi ko sa inyo, pwede kabisaduhin nyo na lang. Although, it will be better kapag mas alam nyo yung equilibrium kaysa sa shortcuts. Sabi ko nga sa inyo, mag-shortcut lang kapag alam na yung concept. Okay. So, yun yung reason why kapag 2-to-1 yung ratio natin, X can be calculated as the cube root of Ksp over 4. Okay. So you will find this handy kasi puro ganito yung question sa part 2. Kahit ito na lang yung gamitin mo, masasagutan mo siya. Okay? So yan yung reason ba't ganyan yung formula kapag ang ratio nila ay 2 to 1 or 1 to 2. Isang cation, dalawang anion, or dalawang cation, isang anion. Okay? So how about 3 to 1 ratio? Pag 3 to 1 ratio, ito yon. Example nun would be aluminum hydroxide. Ito yung nasa Kreml S. Okay. So, aluminum hydroxide. Pakita natin, this will dissociate into Al3 plus and 3OH minus. At equilibrium, their amounts will be X and then 3X. So if we write the Ksp here, we have Al3 plus and OH minus 3. Plug in the X expressions, you get X times 3X cubed. So what is 3 cubed? So yun ay 27, no? And then X cubed times X raised, that is equal to X raised to 4. So to solve for the molar solubility, that is just the fourth root of Ksp divided by 27. So yan yung shortcut natin kapag ang ating cation at anion ay 1 to 3 yung ratio. Okay? Kapag 1 to 3 yung ratio nila, the X can be calculated as the fourth root of Ksp divided by 27. So yan lang. Shortcut, pwedeng kahit ganito na lang. I-recognize mo lang kung 1 to 3 yan, 1 to 2, o kaya 1 to 1. Okay? So dun mo malalaman yung corresponding equations mo. And lastly, we have the 3 to 2 ratio. Tatlong cations, dalawang anion, or vice versa. If that's the case, kapag 3 to 2 yung ratio nila, you can calculate for the molar solubility as the fifth root of Ksp divided by 108. Paano yun nangyari? Okay, paano naging Ksp over 108 yun? Tapos ba't naging fifth root? No? So galing lang din yun sa ice table. Okay? So ipakita natin yung example na to. We have calcium phosphate. Okay, so if you write the equation correctly, you will get 3 calcium 2 plus and 2 phosphate ions. So at equilibrium, the concentration of calcium will be 3x. For phosphate, that will be 2x. Plug it into Ksp. You have concentration of calcium cubed and concentration of phosphate squared. Plug in mo yung x, so this will be 3x raised to 3. This will be 2x raised to 2. So what's 3x raised to 3? That is 27 x cubed times, this will be 4x squared. 27 times 4 is 108. And then x cubed times x squared will be x raised to 5. That's why solving for x will give you the expression fifth root of Ksp divided by 108. Okay, so yun yung reason bakit ganun yung lumabas dito. So as I told you, you can do the ice table, better yon. But if you could remember these shortcuts, that will be also good, no? Kasi ang gagawin mo na lang dito sa shortcuts natin to solve for the solubility is just identify if that's 1 to 2, 2 to 1, 1 to 3, or 2 to 3 ratio. Yung ating cation and anion. So, paano mo malalaman yun? No? Just look at the formula. Ilang cation mapoproduce mo dyan, ilang anion, then you will get the ratio. So, depending on the ratio, you have different ways to solve for the x. And all of those are rooted from the k expression. So, makuha mo naman siya sa k. Pero you can do the shortcuts, ha? Okay? So, yun lang. So now, let's focus on the next part, no? So, diba, when you mix two solutions, they form precipitates. But do they, no? Do they form precipitates ba talaga agad, no? The answer is not all the time, no? Hindi sila agad-agad magfo-form ng precipitate. Bakit? They have to reach certain threshold para mag-form yung precipitate na. So, kailangan may ma-reach silang threshold para ma-form yung precipitate. And what is that threshold? That threshold is the Ksp. Okay. So, kapag na-reach nila yung Ksp pataas, doon na ma-form yung precipitate. However, if mababa yung ating amounts ng ions relative to the Ksp, then hindi tayo maka-form ng precipitate. Okay? So, ano lang yung point ng part ng topic na to? According to this topic, the formation of precipitates is gradual. So, onti-onti, you will reach the threshold when you add your solutions. Pag na-reach mo na yung threshold, yung Ksp, dun na ma-form yung ating precipitates. No? But ano yung i-compare mo sa Ksp para malaman mo kung ma-form yung precipitate? Dito na papasok yung reaction quotient ulit. Okay? Just like yung ating equilibrium, pag-predict natin ng direction, we can use the reaction quotient to tell whether a precipitate will form or not. Okay? Depending on its relative amount with the K. So if our Q is less than the K, that means we have unsaturated solution. So there is no enough ions needed to form the precipitates. So yun yung meaning kapag Q is less than K. Ibig sabihin, onti pa masyado ions natin. So hindi sila mag-form ng precipitates. Okay? However, if Q is equal to K, we are at saturated point. So meaning we are in the balance. Pag yan ay lumagpas, pag yung Q lumagpas sa K, dun na tayo mag-start mag-form ng precipitate. Okay, so because we have supersaturated solution. Okay, so to help you visualize with this, imagine nyo yung tubig pati asukal. Yung kasing primary component para makagawa ng sugar, sugar candy. Okay, kaya gawin yun sa bahay actually. Pero imagine nyo, nabubuo ba agad yung asukal na candy kapag nilagay nyo asukal sa tubig? May sugar candy ba agad kapag nilagay mo yung asukal sa tubig? Hindi, di ba? Ano mangyayari? Pag naglagay ka ng asukal sa tubig, unsaturated yon. Then over time, mapapansin nyo na hindi na nade-dissolve yung ating sugar sa tubig. So, parang ganun din dito. Initially, kapag onti lang yung nilagay mong ions, hindi pa ma-form yung crystals. However, kapag sumobra na yung ions na nilagay mo, you reach the threshold, yung Ksp. Okay? Pag marami ka na nilagay na ions, that's lumagpas ka na sa Ksp value. Doon ka na mag-form ng precipitates. Okay? So, imagine nyo na lang yung sugar analogy natin. Pag nilagay nyo siya, matutunaw, and then later on, kapag sobra-sobra na nilagay mo, nagki-crystallize siya sa ilalim. Okay, namumuo siya sa ilalim. Ganon din dito. Unti-unti, walang precipitate na ma-form, pero pag lumagpas ka na sa threshold, that's the Ksp, dun na siya mag-start ma-form. Okay? Dun na mamumuo yung ating crystals. So let's apply this concept dito sa problem na to. So may mga ganitong questions sa quiz na. So if 2 ml of 0.2 molar sodium hydroxide are added to 1 liter of 0.1 molar calcium chloride, will a precipitate form? Okay. So ang sabi natin, we can tell kung mabubuo ang precipitate if we compare it with the K, no? Yung Q pati K, i-compare natin. Pero paano? Okay. So ganito muna. Ang question kasi dito is, may mabubuo bang precipitate? Okay. So, ano bang precipitate mabubuo natin out of sodium hydroxide and calcium chloride? Okay. Sa tingin nyo, ano kaya yung precipitate na pwede mabuo dyan? Ano yung candidate or possible na maging precipitate dyan? Okay. So, anyone? No? Ano kaya? So, anong precipitate pwede mabuo from sodium hydroxide and calcium hydroxide? That will be? Ano kaya? Calcium hydroxide. Okay? So, pwede natin mabuo yung calcium hydroxide from the two mixture. Okay? Remember yung rules for hydroxide? Ano sabi doon? Sabi sa solubility rules, hydroxide are soluble unless paired with ano? Mali pala yung pagkakastate ko. So, hydroxides are soluble when paired with sodium, lithium, potassium, group 1 metals generally, and barium. Okay? So, dun lang siya nagiging soluble when it is paired with group 1 metal and barium. However, in the presence of other cations, precipitate na siya. Okay. So if you pair hydroxide with iron, precipitate yon. If you pair hydroxide with aluminum, precipitate yon. If you pair hydroxide with calcium, precipitate yon. So ang candidate na precipitate natin dito would be calcium hydroxide. Ito lang eh. Kasi yung NaCl, if we do the double displacement, kapag yung NaCl na form, ionic compound yon. Ions talaga yan. So hindi yan magpo-form ng precipitate. Only calcium hydroxide can be formed as precipitate. Okay? So, yun. So, yun. Yun yung first technique nyo. Identify what are the precipitates that can form. Alamin mo ano muna yung mga pwede mabuo. In our case, that's calcium hydroxide. Then, you write the expression, the solubility for calcium hydroxide. Pakita mo yung expression niya. So, this is solid, precipitate yan, that will dissociate into calcium 2 plus and 2OH minus. Then you write it sa ice table. So, ganun yung technique natin. Identify your precipitates first, then you write the solubility equation. Pakita mo kung paano magdi-dissociate yan. Then, gawa ka ng ice table. So, ayan. Sa ice table, ano yung mga ilalagay natin? Yung concentration ng calcium sa ating solution, pati concentration ng hydroxide sa ating solution. Okay? So, ano ba yung concentration ng calcium sa solution? Okay, basahin uli natin yung problem. Ano ginawa dito? We mix two solutions. We have a solution of this one and a solution of this one. So, ano nangyayari kapag pinaghalo mo yung solution mo? Our ions become diluted, no? So, nag-undergo sila ng dilution process. 'Di ba? Pag pinaghalo mo yung dalawang tubig, pinaghalo mo yung dalawang solution, tumataas yung volume niya eh. So that means the two ions become diluted. No? So ibig sabihin nun, yung mga molarities nila na nakalagay dito, bababa yan. So pag nilagay mo sa solution itong 0.2, bababa yan. Itong 0.1, medyo bababa yan. Na. Okay? So bakit bumababa yung kanilang molarities? Because they become diluted eh. Naging diluted kasi sila. Okay? So, ibig sabihin, to get our initial amounts of calcium and hydroxide, we have to dilute their molarities. Kasi pinaghalo mo dalawang volume. Okay? So, dilute natin yung molarities nila before we write it here. Okay? So, yun. However, ito yung ating pwedeng gawing shortcut, no? However, look at the relative amounts of our solutions. Compared to 1 liter, 2 ml is negligible. Okay? That is 500 times smaller than 1 liter solution. So that means kapag inad mo yung 1 liter, plus 2 ml, the volume of the solution will approximately be equal to 1 liter pa rin. Because again, 2 ml is a very small volume for the liters. No? Okay. So that means since yung ating total volume of the solution can be approximated as 1 liter, the concentration of calcium will be as is. No? So kung ano yung nakalagay dito, yun na yung concentration ng calcium. Bakit? Kasi sabi natin, the final volume of the solution is approximately 1 liter pa rin. Kasi 2 ml is just ilang droplets lang yun. Ilang patak lang yun. Okay? So that's why sabi natin since ang final volume is still 1 liter pa rin naman, 2 ml can be neglected. No? Pwede burahin mo na lang yan. So that means the concentration of calcium will be as is. No? Okay. Yun na lang din. Para hindi na tayo mag-calculate. No? Bakit yun na lang din? Kasi approximately 1 liter pa rin naman yung solution pag dinagdagan mo siya ng 2 ml. Okay? So, di na ako magdi-dilution formula for calcium. Masyadong onte eh. Okay. However, kunwari ito ay 10 ml. Yan, significant yung change, no? Pero in our case, that's 1,000 ml. So, wag ka na mag-dilution, no? Because the final volume of the solution is approximately still 1 liter. Okay? Pero, sa point of view ng sodium hydroxide, yung concentration ng hydroxide yung magbabago by a lot. No? Malaki yung change sa molarity ng hydroxide. Bakit? Kasi it started from 2 ml. Nung nilagay mo siya sa solution ngayon, naging 1 liter na yung total volume. So that means its concentration will vary a lot, no? Malaki yung pagbabago sa kanya. So, alamin natin kung ano yung magiging final molarity niya when we mix it sa solution. We can use the dilution formula, M1V1 equals M2V2. So, to get for the final molarity, that's M1V1 over V2. So, the initial molarity is 0.2 molar. Initial volume is 2 ml. And the final volume is still 1,000 ml. O, in-approximate natin to ha. Kaya 1,000. So, ano magiging molarity niyan? So, that will be 4 times 10 raised to negative 4. Okay. So, ganun kalaki yung pagbabago sa molarity ni sodium hydroxide, no? Compared to calcium. Okay? So, again, bakit yung kay calcium, kung ano yung nandun, yun na rin din yung nilagay ko dito sa ice table. Ang reason is, kasi sabi ko, if you add 2 ml sa 1 liter, that is still 1 liter pa rin. 1 liter pa rin yan. Kasi masyado maliit na to compared to 1 liter. So this can be seen as negligible value. So pwede i-disregard mo na lang yan sa final volume. However, for hydroxide, dun yung significant change, no? Dito nangyayari yung significant change sa concentration. Bakit? Kasi we started with 2 ml of this and then naging final volume natin ay ito, 1,000 ml. So significant yung change niya. So 500 times smaller na siya than the original. Okay? So that means we have to do the dilution formula. And then we found out that the final concentration of hydroxide in our solution is 4 times 10 raised to negative 4. Okay? So, yan. Ang tanong, saan natin gagamitin itong info na to? We will use this info sa Q, reaction quotient. Kasi yung Q, i-compare natin sa K, di ba? Okay, so we will use Q. We will use this concentration sa Q. So, what is the Q for this equation? That is the initial concentration of calcium times the initial concentration of hydroxide squared. So, what's the initial concentration of calcium? 0.1. For hydroxide, that's 4 times 10 raised to negative 4 and then squared. So we find out the value of Q is okay, so the value of Q will be 1.6 times 10 raised to negative 8. Okay, so again, dito sa mga amounts mo, ilagay mo yung initial concentrations nila. You use dilution formula if necessary. Then from this initial concentration, we can get the reaction quotient. Okay. So i-pattern nyo yan sa ating equation. Then you plug in your initial amounts. Then we have the Q. Ngayon, ano yung K nito? Ano yung K ng calcium hydroxide. Ano yung Ksp niya? So, di ba may table akong pinakita sa inyo? Doon tayo titingin. So, for calcium hydroxide, ito yon. The K is 8 times 10 raised to negative 6. Okay, so the K, or the threshold, is 8 times 10 raised to negative 6. So, generally, we can say that Q is less than the K. Okay, so Q is less than the K. So, question, will A precipitate form? Hindi. Okay? So, hindi mabubuo yung precipitate. Bakit? Kasi Q is less than the K. Hindi niya na-reach yung threshold. Pwede rin ito gamitin as yung yung predicting the direction of the reaction. Okay? Di ba nung ginagawa niyo dun sa lecture? You compare Q with K. Kapag Q is less than K, the reaction is going to the products. In our case, since going to the products yan, wala tayong precipitate pa. However, if Q is greater than K, going to the reactant yon, di ba? To the left yung direction ng reaction. Ibig sabihin, mamumuo na yung precipitate. Okay? So, ganun lang. So, in summary, if Q is less than K or Q is equal to K, wala tayong precipitate. But, if your Q is greater than K, you will form a precipitate because the equilibrium will be shifted to the left. So, mabubuo na to. Okay? So, ganun lang. How about this one? So, for this problem, may nilagay akong isang ganito sa quiz. No? So, for this problem, ang meron dito is you have a mixture of bromide and chloride ions na 0.02 molar. Then, ang mangyayari, maglalagay ka daw ng Ag to precipitate only AgBr. So, visualize natin. So, in this solution, you have Br minus, and then you have Cl minus. Okay, so para silang 0.02 molar. Ang tanong, gaano karaming silver ang kailangan ko ilagay para ang ma-precipitate lang ay ito, not this. Possible kaya yun? So, tingnan niyo, possible yun, na isa lang yung ma-form kong precipitate, yung sa chloride hindi. No? Kasi both of them will form precipitate. No? Pwede ka maka-form ng AgBr, pwede maka-form ng AgCl, ito yung itsura nila. Ay, yung isa yellowish lang. Okay? So, possible kaya yon na yung isang ion lang yung i-precipitate ko compared sa isa? Although parehas silang nasa solution. That's possible. Okay, possible yan. Paano? This is the concept of fractional crystallization. Okay. So, concept ng fractional crystallization. So, parang similar to sa fractional distillation. 'Di ba? At different temperatures, iba yung nag-evaporate. Dito naman, at different concentration, iba-iba yung ions na na-form. Okay? So, since we already know that yung ating precipitate, di yan bigla-bigla na-form, no? Pwede natin i-apply yun dito. Okay, that yung precipitates natin, hindi agad-agad yan ma-form unless it reaches the threshold, the Ksp value. Okay? So, paano natin to sasagutan? So, using the Ksp expression for AgBr and AgCl, we can determine gaano karami yung Ag na kailangan to reach that threshold. Okay? So, again, paano natin to sasagutan? Using the Ksp for AgBr and the AgCl, we can determine kung gaano karaming Ag ang kailangan to reach that threshold. If you don't want to precipitate the salt, wag mo abutin yung threshold, no? Your concentration must be less than that threshold. So since sabi natin dito, ayaw natin ma-form yung AgCl, that means the concentration of Ag must be less than the threshold for AgCl. Okay? So ganun yung gagawin natin. So let's apply that in math. Okay? So we have AgBr, it will dissociate into Ag plus and Br minus. AgCl, this will dissociate into Ag plus and Cl minus. So each of them, may iba't ibang Ksp expression sila. And for AgBr, that's equal to, tignan natin dito, AgBr, 7.7 times 10 raised to negative 3. Ah, 13 pala, sorry. Negative 13. 7.7 times 10 raised to negative 13 AgBr. And for AgCl, that's 1.6 times 10 raised to negative 10. 1.6 times 10 raised to negative 10. So Ksp equals AgCl 1.6 times 10 raised to negative 10. Okay. So from this idea, alamin natin kung ano yung threshold concentration ng Ag, no? Para mabuo ito at para mabuo ito. So alamin natin yung corresponding concentration ng Ag para malaman kung kailan mabubuo itong precipitate at ito. So how? You just rewrite the Ksp into Ag, okay? So that will be given as Ag equals Ksp divided by Br. So ganun din dito. So you have your Ag equals Ksp over the concentration of Cl. Paki-plug in. So we have 7.7 times 10 raised to negative 13. Anong concentration ng Ag ng Br? Sabi dito, 0.02. So for the AgCl naman, Ksp is 1.6. And the concentration of Cl is 0.02 din. Yung kasi sabi sa problem. Okay. So the threshold for AgBr, para mabuo yung precipitate na yan, kailangan natin ng 3.85 times 10 raised to negative 11 molar Ag ions. Ganang karaming Ag ions kailangan mo para mabuo ito. Okay? However, para mabuo yung AgCl, gaano karami? Calculate natin. So that will be 1.6 times 10 raised to negative 10 divided by 0.02. 8 times 10 raised to negative 9. Okay? So yan. So sabi natin, para mabuo yung AgBr, the concentration of silver must be greater than this. No? Greater than this para mabuo to. And yung AgCl, para mabuo yan, the concentration of silver must be greater than this. 8 times 10 raised to negative 9. So, ibig sabihin, sino yung unang mape-precipitate? Ang unang mape-precipitate ay yung AgBr kasi onti lang yung Ag na kailangan niya. Then, yung last na mape-precipitate ay yung AgCl kasi medyo marami yung kailangan niya. So, ito, negative 11. So, ibig sabihin, onti lang, ma-form na to. However, ito, medyo dagdagan mo pa para tumaas yung concentration, then saka na ito ma-form. So, that means possible tong question na to, na yung AgBr muna yung ma-form. At ito, pwede hindi siya ma-form. Okay. So, ano yung concentration of Ag that is required to form only AgBr, not AgCl? So, the concentration of Ag needed to precipitate the AgBr only is within this range, no? So, within this range, no? Tapos, explain ko kung bakit ganyan yung sagot natin. Okay. So, ito dapat yung range ng Ag ions in order to precipitate the AgBr and not the AgCl. Okay. So, bakit greater than 3.8 times 10 raised to negative 11? Kasi sabi nga natin, Q must be greater than K. So, that means yung concentration natin should be greater than this. Okay. Ito kasing given sa K. So, kailangan mas mataas pa dito para mabuo itong AgBr. However, it must be less than this from the AgCl. It must be less than this. Kasi kapag ito lumagpas kapag yung concentration ng Ag lumagpas ka dito, mabubuo na rin itong AgCl. Okay? So again, if you want to precipitate only the AgBr, not the AgCl, the concentration of Ag must be within this range. It should be greater than this, but less than this. If the concentration of Ag is greater than this, then mapo-form siya. Mapo-form yung AgBr precipitate. Pero, kapag lumagpas ka dito, yung AgCl mabubuo din. So, kung gusto mo, huwag ka lumagpas doon. Okay? So, kumbaga, to answer problems like this, naglagay ako ng isang ganito sa quiz nyo. Ang gagawin nyo lang is, identify mo ano yung lower limit and ano yung upper limit. Yung lower limit, yun yung concentration ng precipitate na gusto mo kunin. And yung upper limit, yun yung ayaw mo makuha na precipitate. You determine the metal concentration that will form the precipitate. Okay? So, yun. Since ayaw mo mabuo to, so siya yung upper limit. Hanggang dun lang dapat. So, ito yung gusto mo mabuo, yun yung magiging lower limit mo. Okay? So, this is the range of the concentration of silver needed to precipitate silver bromide, but not AgCl. Okay? So, kunwari, tinanong kayo sa quiz, no? Kunwari, sa midterm exam, kunwari, tinanong sa inyo, sino yung unang mape-precipitate dito? AgBr, AgCl? So, you can infer the idea based on their solubility. Kapag mababa yung kanilang solubility, ibig sabihin, siya yung unang mape-precipitate. O kaya, other than the solubility, you can use the Ksp to compare sino yung unang ma-form. Kung sino may lowest na Ksp, yun yung unang magpe-precipitate. No? Okay. So, ito yung unang magpe-precipitate kasi siya yung lower compared to this. Okay. Ito question. Is it possible to form only AgCl? Pwede ba yung AgCl lang i-precipitate ko? Not the AgBr. Is that possible using silver? The answer is no. Hindi mapo-form yung AgCl alone. Why? Kasi as AgCl forms, AgBr formed already. Nabuo na siya. Kasi siya yung nasa lower limit. Siya yung unang magpe-precipitate. So, ibig sabihin, ito lang yung pwedeng ma-form ito. Kunwari, ito yung gusto mo ma-form, possible yon. Kasi siya yung mauuna eh. Pero kunwari, ito yung gusto mo ma-form, ayaw mo neto, impossible yon. Kasi before pa to ma-form, mauuna na to. Okay? So, yun yung idea ng fractional crystallization. So, depending on the Ksp values, pwedeng mauna ma-form yung ating ions compared to the other. Just look at the extent of the K value nila. Kung gusto mo malaman kung ano yung corresponding concentration para mabuo sila, just use the Ksp. No? Gamitin mo lang yung Ksp natin. Then you will write it as this. No? The lower limit, ito yung gusto mo ma-form na precipitate. Higher limit, ito yung ayaw mo mabuo na precipitate. So again, for this problem, hindi pwedeng AgCl lang mabuo. Kasi kapag ito yung binuo mo, mabubuo din yung AgBr. So, ang possible lang ay yung AgBr mabuo, ito hindi. And not the other way around. Okay? Not the other way around. Okay? So, yun lang. And punta na tayo sa last part. No? So, for the last part, this is about the common ion effect. So, basically, istable pa rin to. Okay? So, common ion effect is one of the applications of Le Chatelier principle in your lecture. Ano sabi doon? In the presence of common ions, the solubility of the salt decreases. No? Okay, bakit? No? Kasi in the presence of common ions, ano nangyayari? Sabi doon, di ba sa Le Chatelier principle, when you add ions, it shifts the equilibrium. No? Okay. In our case, yung ions natin nasa product side for equilibrium, solubility equilibrium, di ba? Nasa product side yung ions natin. So when you add ions on the product side, it shifts the equilibrium to the left. Hence, the precipitate will be less soluble. Okay? So let's apply that in calculations. Okay? So yung theory, alam nyo na siguro yan. No? Pero yung calculation, let's show na bababa talaga yung molar solubility niya. in the presence of common ions. So let's have this. What is the molar solubility of AgBr in pure water and in 0.001 molar sodium bromide? So first things first, you write the solubility expression. So yun yung unang gagawin nyo parate. And then you write it in the ice table. Okay, nothing has to be written sa left. Wala kang ilalagay dyan kasi yan ay solid. It doesn't affect the equilibrium. Okay, so punta muna tayo. Pure water. Pag sinabing pure water, wala kang ibang ions other than water. Okay. So 0, 0 yan. So the change will be positive x and the equilibrium will just be x. So we say Ksp is equals to x times x, or x is equal to the square root of Ksp. So alam nyo na kung bakit naging ganyan, di ba? Okay, so shortcut ko na. So what's the solubility of AgBr in pure water? The Ksp, by the way, is 7.7 times 10 raised to negative 13. Okay. So again, paano natin nakuha to? Because Ksp is this times this. This times this. Kaya x is equal to the square root of Ksp. 1 to 1 yung ratio eh. Isang cation, isang anion. So x is the square root of Ksp. So what's the molar solubility in water? The molar solubility is 8.8 times 10 raised to negative 7 molar. So yan yung molar solubility ng AgBr in water alone. How about in 0.001 NaBr? So according to Le Chatelier principle, since nag-add tayo ng Br, yung common ion natin dito ay yung Br minus. Remember, NaBr will dissociate into Na and Br ions. So nagdagdag ka ng common ion sa equilibrium mo. Since nagdagdag ka dito, parang si Elsa lang. So, since nagdagdag ka dito, it will shift the equilibrium to the left. Ibig sabihin, this precipitate will be less soluble. Okay? So, it will shift the equilibrium to the left in addition when you add common ions. Okay? So, yan. So, let's show it mathematically para makita natin kung totoo ba yung concept. Okay. So, apply natin yung dito. So, babaguhin natin to. So, may dinagdag tayo sa ating initial amount. Now, we have 0.001 molar Br minus from NaBr. Okay? So, this will still be plus X kasi sa product to, may 0 sa product. So, positive talaga doon. And the equilibrium amount of Br is 0.001 plus X. Okay? So, Ksp is now, again, pakita ko na lang. That's the concentration of Ag and the Br minus. So, for Ag, that's X. However, yung Br, magbabago to. That will be 0.001 plus X. Okay? So, nagbago yung ating equilibrium equation. That means, may shift sa equilibrium. Okay? So, may pagbabago sa ating equilibrium. Okay, so let's solve for the molar solubility. Let's solve for X. Okay, so dito kailangan natin gumamit ng algebra. Okay, so I will let you derive the equation. So that will be x squared plus 0.001x minus Ksp. Okay, so this is the quadratic equation. This is the polynomial that we can derive out of this. I distributed x dito, so I got this. I distributed x doon, so I got x squared. I moved the Ksp to the right para sama-sama sila. Use the quadratic equation to solve for the x value. Of course, dalawa yan. Dalawa yung x values mo. By the way, wala tayong kawala sa quadratic equation pag ganito. Hindi natin magagamit yung small x approximation. Bakit? Pag sinabing small x approximation, initial amount ng reactant. Kaso hindi nagmamatter yun eh. So, wala tayong magagawa. We have to do quadratic equation talaga. Okay. So, solving for the value of x, we have 7.7 times 10 raised to negative 10 molar. Then the other value is negative 1 times 10 raised to negative 3 molar. Obviously, yung positive root yung kukunin ko. So the molar solubility in the presence of 0.001 molar NaBr will be 7.7 times 10 raised to negative 10. Okay, so from this calculation, napatunayan ba natin that in the presence of common ion, the solubility decreases? Napatunayan ba natin? Yes. Bakit? Look, in just pure water, ito yung solubility niya, times 10 raised to negative 7. But in the presence of common ion, in our case, Br minus, naging negative 10 yung ating solubility. It became much lower. Mas lalong bumaba. So, ibig sabihin nun, totoo yung Le Chatelier principle. That when you add common ions, it shifts the equilibrium to the left, hence the precipitate becomes less soluble. Okay? Iba pa yan sa diverse ion effect. Okay? Yun yung nasa last lecture nyo sa, nasa last lecture nyo, di ba? Last chapter sa lecture, di ba? Nakakwento na ba sa inyo yung gamma, ionic activities, no? So, iba pa yon. So, yun yung, major counterpart ng common ion effect. So, nangyayari naman doon, when you add diverse ions, it shifts the equilibrium to the right. So, kunwari, naglagay ka potassium nitrate, it shifts the equilibrium to the right. It makes your precipitate more soluble. Okay? Yun yung concept doon sa, sa common diverse ion effect or sa salt effect. Iba yun dito sa common ion effect. Kasi kapag common ion, shift to the left. Pag diverse ion, shift to the right. Okay? So, yun. So, sana hindi kayo malito sa mga ganun, ha? Kasi madali lang naman. Pag common ion effect, to the left. Pag salt effect or electrolyte effect or diverse ion effect, to the right yun. Yung shift. Mas magiging soluble yung precipitate. Okay? And iba naman yung calculation doon. Kasi instead of using concentration, we solve for the activities. Kaya nilalagyan natin ng gamma. 'Di ba? So, iba pa yung calculation doon, ha? Okay. So, yan. So, other factors that can affect the solubility other than the common ion effect is the pH. Okay? So, if you have insoluble base such as aluminum hydroxide, it will dissociate better in acidic solution. Yun yung reason ba't siya yung nilalagay sa stomach natin kapag tayo ay na-acid, no? Aluminum hydroxide, magnesium hydroxide sa Kreml S. Pag nilagay mo sa tiyan mo yon, matutunaw yon. Pero kapag sa tubig mo lang nilagay yon, hindi yun natutunaw agad-agad. Okay? So kasi ito yung sabi dito. Insoluble bases will dissolve better in acidic solutions. Sabihin, mas matutunaw sila sa acidic medium. Okay? For insoluble acids naman, matutunaw sila better in basic solutions. Bakit? Le Chatelier principle lang din. Okay? So, suppose we have this magnesium hydroxide. This is insoluble base. Kaya nga solid yung Kreml S dahil dito. Magnesium hydroxide, aluminum hydroxide. Okay. So, this is insoluble base. Saan to mas matutunaw? Sa acidic medium. Why? Apply natin yung Le Chatelier concept na, yung Le Chatelier principle. Bakit siya mas magiging soluble kapag nasa acid? Kasi ganito. Kapag itong ating precipitate nag-dissociate into ions, yung acid, makikipag-react yan with the OH. So kapag nag-react yan with OH, they will produce water. So that means the concentration of OH will be lower. Okay? Kasi mababawasan yung OH kasi nag-react siya with H+ to produce water. Na-neutralize silang dalawa. That means bababa yung concentration ng OH from this. And as a result, sabi ni Lechate, no, sa kanyang principle, if you decrease the products, the equilibrium will be shifted to the right. Okay? That's why yung ating magnesium hydroxide, it will be more soluble in acidic media. Kasi in acidic media, yung OH mababawasan, okay, as it reacts with H+ to produce water. Mababawasan yung concentration niya, so the equilibrium will be shifted to the right. However, kapag yan ay nasa basic solution, anong common ions? Yung hydroxide. No? Kapag basic solution, may hydroxide, di ba? So, tataas lalo yung concentration ng OH, hence the equilibrium will be shifted to the left. It will become less soluble. Okay? So again, pag insoluble base, it will be dissolved better in acid. Pag insoluble acid naman, it will dissolve better in basic solutions. No? So, ganun lang. So, for this problem, alamin natin at what pH siya mas magiging soluble. At what pH mas magiging soluble to. Okay. So, yan. So, paano natin malalaman at what pH to magiging soluble? So, alamin natin yung OH concentration. From OH concentration at equilibrium, pwede natin malaman yung pH na tong solution na to. Okay? So, let's plug it into our ice table. So, initially, wala tayo niyan. Then, magiging positive yan as it dissociates. However, 2x for the OH kasi may coefficient na 2. This will be x. This will be 2x. Ksp equal concentration of Mg 2 plus concentration of OH minus squared. So, Ksp is x times 2x squared. Or, since 1 to 2 yan, that is x equals the cube root of Ksp over 4. So, dito lang din galing yan. So, let's solve for x, the molar solubility. Okay, so Ksp is 1.2 times 10 raised to negative 11 divided by 4. 1.44 times 10 raised to negative 4 molar. Let's solve for the concentration of OH. That is 2x. So this is 2.88 times 10 raised to negative 4 molar. And later on, solve for the POH, negative log of OH. It's 3.54 and the pH is equal to 10.46. So the pH of the solution of magnesium hydroxide is 10.46. Mabilisan ko na lang ginawa. Kasi I know, umay na kayo dito. Sanay na kayo dito. No? So ganun lang. Ksp, you get the x. Then to solve for the pH, you determine the OH. That's 2x, so twice the x. And from this concentration of OH, you get POH and convert it to pH. No? So that is the pH of this solution. Ang tanong, saan siya mas magiging soluble? Anong pH values? So sabi natin, this will be more soluble in pH that is acidic. No? So that means pH less than 10.46, dun siya mas magiging soluble. Pero at pH greater than 10.46, dito siya mas magiging less soluble. Okay? So, ganun. So, at pH less than this, at equilibrium, mas magiging soluble siya. Kasi mababawasan tong OH. Kasi our H plus will react with OH para maging water. So, mababawasan to. The equilibrium will be shifted to the right at acidic pH. But at pH higher than this, at equilibrium pH niya, doon siya mas mahirapan mag-ionize. No? Mahirapan siya mag-ionize kasi mas maraming products, no? So the equilibrium will be shifted to the left. So it will be less soluble. Okay? So may ganitong question sa sa quiz ako nilagay. So, ang question doon is, what is the pH of this solution? Ganito lang yan. Okay, you solve for the X, then you plug it into your equilibrium concentrations. If OH yon, kunin mo yung POH, then pH. Okay, so medyo similar dito yung ginawa kong problem. Then, once you have this, any pH lower than this will make the solution, will make the precipitate more soluble. But any pH higher than this will make the precipitate less soluble. Okay, so yun lang yung concept doon. Bakit? Kasi may kinalaman yun sa reaction ng H sa OH. Okay? So, yun lang yung reason bakit gano'n. And that's the end of our lesson. Okay? So, basically, wala naman tayo masyadong dinagdag na. No? So, everything has been discussed na naman before. Alam nyo na paano mag-ice table. Alam nyo na paano mag-KSP. Siguro, yung nadagdag lang sa atin is yung additional examples ng de Chatelet principle. So, ano yung mga additional example natin doon? Yung common ion effect. We just proved na tama yung concept based on calculation. Nakita niyo, bumaba naman yung, di ba? Solubility niya. So, tama yung concept na to. And that applies also to acidic and basic salts. No? So, kapag acidic, if you have a basic salt, it will be soluble in acidic solutions and less soluble kapag nasa basic solutions. So, yun lang yung nadagdag sa atin today. Its application. Okay? Yung application ng de Chatelet principle with mathematical proof. Okay? So, yan. Nakita nyo naman yung equations natin. And also, yung dagdag pa sa atin is yung concept ng fractional crystallization. So, yung ating precipitate, di yan agad-agad na bubuo. It has to meet a certain threshold. Okay? The threshold is the K, the Ksp. Okay? So, kapag ang ating reaction quotient is less than the Ksp, hindi mabubuo yung precipitate. However, kapag greater than yung Q natin sa Ksp, dun siya mabubuo. Okay? And we can use that concept when you want to separate ions, no? Okay, so yan. Pwede nyo i-apply yung concept na yun dito sa ions. Ano yung practical application na to? Sa Maynilad, no? So, kaming mga chemist, although di ako sa Maynilad, hindi ako nag-industry talaga eh. Kasi nakakapagod daw. Okay. So, sa Maynilad, ang ginagawa ng mga chemist doon is, di ba, napapansin nyo, they test chlorides, di ba? And then magnesium, calcium, etc. So, tingin nyo, paano nila nalalaman yon? One way is to do this. Okay, yung crystallization or fractional crystallization. Yung for example, yung magnesium and yung calcium sa ating water. Pwede mo malaman kung gaano karami calcium doon when you precipitate it as calcium hydroxide. Yung magnesium hydroxide din, ganun din. Okay. So unang ma-precipitate, see? Tignan natin yung Ksp. So, unang ma-precipitate ay si okay, si magnesium hydroxide yung unang ma-precipitate, no? So, kung gusto mo alamin total magnesium sa solution. So, i-precipitate mo muna siya. Then, saka mo na malalaman si calcium pag tinaasan mo pa yung concentration ng OH sa solution mo. Okay. So, doon namin nalalaman yung mga percent calcium, ppm calcium, ppm magnesium sa likod ng water bottles. So, ganun ginagawa namin. We precipitate these two ions so we can quantify them. Okay. So, yun. So, that's one of the many applications nito. But again, focus lang muna tayo sa basics na. Kasi hindi nyo naman gagawin yan in the future. Okay. So, yun lang. That's all for our midterm period. So, we are done. Again, focus tayo dito sa calendar. So, tapos na tayo sa ating session. That means by Friday, di na tayo magkikita. Kailan tayo magkikita uli? Itong week na to. Itong third week pala. And then fourth week nga. Dito sa fourth week ng March, dito na lang ulit tayo magkikita for the grade consultation. Okay, so compute ko na yung midterm grades nyo after the midterm exam. Then, yun, kakonsult tayo. Ano mga pwede i-improve and etc. No? And to my new students, ang technique naman namin usually sa mga former students ko ay ganito. Di ba mapapansin nyo sa mga former students ko, mahirap yung midterm period kaysa sa finals. Sa Anachem ganun din. Mahirap lang yung midterm period sa di ba sandamukal na equations pinakita ko sa inyo no for the rest of the months no. So yung midterm period yan talaga yung mahirap, so expect mababa grade nyo sa midterm period unless mataas talaga scores nyo. Pero pagdating sa final period, bawin-bawi naman kayo. Okay? Kasi yung mga topics sa final, iniisihan ko na lang para makabawi talaga. Okay? So whatever your midterm grade is, malaki pa yung improve niyan. So ask my former students, malaki yung improvement sa grades nila din eh. So they started with okay lang na midterm grades, pagdating sa final grade, tumaas na. So ganun din sa Anachem. Okay? So yun. So with that, maybe we're good na, no? Nasabi ko na naman yung ibang announcements. No? So again, to follow na lang yung worksheets, no? Pasensya na, medyo maraming ginagawa, no? Pero ihahabol ko yan para makapag-review kayo. Okay? And also, don't forget, meron akong in-upload na mock exam. Pwede nyo i-take yun para ma-check nyo kung ready na kayo sa midterms. No? Okay. So, yun. So, that will be all for our session today. So, I'll see you again next week, no, for the grade consultation. Okay. So, let's check. Ayan. So, thank you po. And good luck. All the best, no. I am hoping na yung inyong scores ay 80 pataas, no. Okay. So, that will ensure you a grade of B plus or A. Okay. So, thank you. And yan. So, I'll see you again. Bye-bye. And a copy of the recording will be uploaded on YouTube.